Today we are discussing oxidation and reduction. First of all, we have classical concepts of oxidation and reduction. Or what is oxidation? Oxidation is basically the addition of oxygen or removal of hydrogen in an ion in a compound or in a species, or the addition of electronegative element or removal of electropositive element. Okay, you can see here addition of oxygen takes place here in those two examples here, and this is oxidation. Removal of hydrogen takes place in these two reactions, and this is oxidation. What is reduction? Reduction is basically addition of hydrogen or removal of oxygen. It is basically the reverse of oxidation. Okay, or addition of electropositive element or removal of electronegative element. Okay, you can see here in the examples that hydrogen is added here in Cl2 and oxygen is removed here from ZNO. This is reduction. Okay, valency concept of oxidation reduction. Like while solving any question related to oxidation reduction, you have asked you have to check all these concepts of oxidation. Okay, like you can oxidation is oxidation taking place or reduction taking place. So oxidation is like valency concept. According to valency concept, we have to check the valency. If the valency increases, positive valency increases, or negative valency decreases, okay, then it is oxidation. You can see here oxygen has zero oxidation state, like it increases +2, it increases +2, so this is oxidation. You can see in reduction, positive valency decreases while negative valency increases. You can see here positive valency +2 of Hg decreases. You can see here it is +1 here, so this is reduction of. Okay, oxidation number concept of oxidation reduction. Okay, according to this concept, like if oxidation number of an element increases, this is called oxidation. If the oxidation number decreases, then it is reduction. You can see here manganese from 7 to 2, manganese here from 7 to 2, and this is reduction. Okay, and iron from 2 to 3, this is oxidation. Okay, modern or electronic concept of oxidation reduction. According to this concept, oxidation is the loss of electron from an element or a species. Okay, this is also called de-electronation or loss of electron. Okay, here you can see iron loses electron and 2 electrons from 0 to 2 oxidation state. Iron loses electron, 1 electron from 2 to 3, and chlorine loses electron from -1 to 0 oxidation state. Okay, and reduction is totally opposite. Okay, gain of electron by an element or an atom or an ion is called reduction. This is electronation. Oxidation is de-electronation. Okay, removal of. You can see here iron's oxidation number decreases from 0 to -1. You can see here increase in negative valency is reduction. You have studied previously, like in this topic, and you can see here from +3 to +2 positive valency decreases. This is reduction. Okay, concept of oxidant or oxidizing agent. Okay, the subspecies which reduces itself but oxidizes other species, reduces itself, is the oxidizing agent or called as oxidant. Okay, here some examples. Like here you can see electronegative reactors NO, FCl, metallic oxides Li2O, Na2O, CO2 is non-metallic. It's like this is non-metallic. You can see it in here. Okay, metallic oxide, some non-metallic oxide act as oxidizing agents. Okay, neutral compounds, like written here KMnO4, H2SO4, and these are the examples of oxidizing agent. Okay, what is reducing agent? Reducing agent is that one that reduces others and oxidizes itself, like it donates electrons to the other species and reduce it. Okay, important reducing agents or reductants, like metals here, these are the reducing agents. Okay, metallic hydrides are reducing agents, hydroacids are reducing agents, organic compounds like aldehyde, formic acid, oxalic acid, tartaric acid are reducing agents as well. All neutral compounds or ions in their lowest oxidation state are reducing agents, but in oxidation the neutral compounds or ions which are in their higher oxidation state act as oxidizing agent. Examples are given. Okay, here are some amphoteric oxides which act as both acids, both oxidizing and both reducing agents. Here are some examples. Okay, these are the amphoteric oxides. Okay, like we discussed this topic in our practice questions. Okay, last video. Okay, you can see that video. Oxidation number, it represents the number of electrons gained or lost by an atom when it changes in compound from free state. Okay, if an electron loses electron, positive sign. If an electron gain electron, then it is negative sign. But real charges, but it represents real charges in case of ionic compounds and imaginary charges in case of covalent compounds. Maximum oxidation number of an element is equal to their number of group in the periodic table. So you can see here all the elements of the periodic table have these oxidation numbers. You can remind these things if you ask about in general, but mostly you have given the questions like or the reaction is given and they told you that what is the oxidation number of that element, like iron, sodium, okay, in that compound. Okay, oxidation number for coordinate bonds, how they are written, like for A part, like if we have two electronegative atoms, like the higher electronegative atom will get the negative, negative oxidation state. Like you can see in H2SO4, oxygen is more electronegative. Okay, oxygen is more electron, so it will get -2 oxidation state, but sulfur will get +2 oxidation state. B part, if we have like two same electronegative atoms, then the electron donor will get the positive oxidation state, while the acceptor takes the negative oxidation state. In example is Na2S2O3. Okay, there are C, when there is, like you can say, when coordinate column is formed from higher electronegative to lower electronegative, then no change will be shown by both the elements, this which is bonded by coordinate column. For example, in CH3CN methyl cyanide. Okay, oxidation state is defined oxidation number per atom for all practical purposes. Okay, rules, study out these rules as well. Okay, these are general things. In free states, elements have 0 oxidation state. Neutral molecules also have the sum of all the oxidation state in a neutral element. Neutral compound is 0, but in charged complex ions, the sum of oxidation number of all the element is equal to their charge, like charge present on that complex ion. Okay, oxygen show -2 in all its compounds, but in peroxides it has -1, and in OF2 it has +2 oxidation state. Okay, hydrogen has +1 oxidation state, but in metal hydrides it has -1 oxidation state. Okay, I write structure for Na2S2O3. Okay, this is the explanation. Okay, here you have oxidation states of manganese in its compounds. Okay, oxidation state can be fractional -0 as well as positive. Alkali metals show +1 always, except hydrogen. Hydrogen has -1 in its metal hydrides. Okay, oxidation states as a periodic property, 1A has +1, 2A has +2. Okay, fractional oxidation state are present in KO2, SO2, RbO2. Okay, oxygen has -1 by 2, -half oxygen state in those compounds. Okay, these are sample questions here related to oxidation number and oxidation state. Okay, redox reactions, we will discuss this in another video. This is for oxidation and reduction only. Try to remind these concepts or try to apply them in questions. Okay.